Good morning, afternoon, evening, whatever it might be when you're watching this video. Today we're going to go through chapter 3.1, which is quadratic functions and parabolas. The graph of the quadratic function f of x equals ax squared plus bx plus c is a parabola with a turning point called the vertex. Now the basic quadratic function is y equals x squared, as you can see graphed here on the graph. Okay. It has a turning point of 0, 0, which is your vertex, and from negative infinity to 0, as we work this way, we can tell that this function is decreasing. And then from 0 to positive infinity, we can tell the function is increasing. I feel like that's pretty basic. Decreasing, increasing, decreasing is going down, increasing is going up. So, we'll get a little more specific with increasing and decreasing functions. A function f is increasing on an interval if for any x1 and x2 in the interval, when x2 is greater than x1, basically we're going from a smaller number to a larger number, it is true that f of x2 is greater than f of x1. Okay, so if it's increasing, basically what we're saying is as the x increases in size, the y also has to increase in size compared to the previous y. And for decreasing, it kind of works the opposite way. A function f is decreasing on an interval if for any x1, x2 in the interval, when x2 is greater than x1, it is true that f of x2 is less than f of x1. The quadratic function y equals negative x squared has the form y equals ax squared, and a is less than 0. So it opens downward with a vertex of 0, 0. Alright, so in contrast to the y equals x squared function here, where it opens upward because our a here is positive, if we have a negative out front here, it basically flips and opens into a downward curve. That's all this is saying. So if a is less than 0, it opens downward like that. If a is greater than 0, it opens upward like the one above. Now let's look at what happens if we have a fraction, okay, especially a fraction that is between 0 and 1 in front of our x squared. Okay, so with it is positive, so it's going to open upward, but let me make sure, yep. But with it, what changes is, if I'm looking kind of a sketch graph of it, if let's go from negative 2, negative 1, 0, 1, 2 for our x, for our y. If I plug negative 2 in for x, negative 2 squared is 4. 4 times a half is 2. If I plug in negative 1 squared is 1 times a half is a half. 0 is 0. 1 should also be a half, and 2 should be 2. So if I'm just kind of sketching it here, and y'all are more than welcome to do this on the calculator. But if I'm just sketching it here, I'm going 0, 0. I'm going 1.5, so about right there. And then I'm going 2, 2. And I'm going 1.5, so 1.5 here. I'm going negative 2, positive 2 here. And it, like I said, it opens upward because that a out front, that half, is positive. Okay. But what we notice here, compared to your regular x squared graph, is that this graph is actually slightly wider. So it doesn't increase as fast. If you notice with a regular x squared graph, what will happen is you'll have y equals x squared. So your xy will look something like negative 2, negative 1, 0, 1, 2. And I'll plug negative 2 in. Negative 2 squared is 4. 1 squared is 1. 0 squared is 0, 1, and 4. So if you notice, if you look at any of these points around it, this one only goes up to a half. This one jumps up to 1. The 2 here only jumps up to 2. This one jumps up to 4. So your regular graph of your x squared increases a lot quicker. This one increases slower. So that fraction slows that graph down. You still are concave up, right? And you have a minimum here. It opens upward, but it does so at a slower rate, so to speak. And we'll get into that more throughout the rest of chapter 3. So let's ease on to the next one. The vertex, which is the point where the parabola turns, is a minimum point if a is positive, a maximum point if a is negative. Okay, so still talking about that a out front, right? So the vertex is the point where the parabola turns. It's a min or a max. If that a is positive, it's a min, because if the a is positive, your function looks like this, right? So you have a minimum right there at your vertex. But if your a is negative, your graph's upside down, and your vertex is now maximal. That's kind of how it works. The vertical line through the vertex is called the axis of symmetry, and its equation is x equals negative b over 2a, with the equation in the form y equals ax squared plus bx plus c. So that's where you get your b and your a from, your c as well. Now the vertex point will be negative b over 2a, comma f of negative b over 2a. Now I'm going to show you how to find the vertex point by hand, but eventually in this lecture I'm going to show you how to find it on the calculator, and I'm sure that pretty much everybody is going to utilize that method once I show it. So let's find it by hand first. We're going to find the vertex of negative 2x squared minus 4x plus 6. Okay. So the first thing I'm going to find is the negative b over 2a. That'll be our x point, and we need our x point so we can plug it back in the equation and find our y point. Okay. Now our b here is negative 4. So it's going to be negative 4 over 2, and our a here is a negative 2. You have to keep the signs with your numbers here. So I wind up with a positive 4 over a negative 4, which reduces to a negative 1. So my x point of my vertex is going to be a negative 1. I still need to find my y point. To find that y point, I'll take this x point that we found here and plug it back into my equation. So we will go negative 2 times negative 1 squared minus 4 times negative 1 plus 6. Now negative 1 squared is positive 1 times negative 2 is negative 2. Negative 4 times negative 1 is positive 4. And then I'm going to leave that positive 6 there. Now negative 2 plus 4 is positive 2. Positive 2 plus 6 is 8. So my vertex point here is negative 1, 8. Okay. A hint, if you want to check it on your calculator, go to y1, plug in negative 2x squared minus 4x plus 6, graph, go to graph, and graph it. Okay. Now because we've got a negative a out front, it's going to be kind of like a frowny face. It's going to be concave down, which means we're going to have a maximum point. The vertex is the same as the maximum point. So if you go second calc, max, left bound, right bound, guess, you can get your calculator to find the maximum point for you. The maximum point here is the same as the vertex. So essentially your calculator can find the vertex for you. I will go over this with the TI-84 calculator on another example, but there's a little cheat sheet for you early. Alright, example 1. R of x equals negative 0.1x squared plus 600x. Find the vertex and the axis of symmetry. Okay, now let's review something real quick. The axis of symmetry here is found by the equation x equals negative b over 2a. So essentially it's just your x point and your vertex. Okay, so what I'm going to do here is I'm going to answer some of these other questions. I'm then going to graph this and show you how to find the vertex and axis of symmetry using your graph function on your calculator. I already talked through it with the last example, but I'm going to show you how to do it on your calculator soon. But there's some questions we can go ahead and answer before we have to flip over to the calculator. First one being, is the vertex a max or a min point? Because our a out front is negative, we should already know that our vertex is going to be a max point. Now, of course, we're going to graph the function and find some points. And then once we graph it, we need to say for which x values the function is increasing and for which x values the function is decreasing. Okay, so let's go to the TI-84 calculator. Let's graph this, find the vertex, the axis of symmetry, some additional points, and then let's state where the function is increasing and where the function is decreasing. I'll see you at the TI calculator. Alright class, we're over here at the TI calculator. We're going to go to y equals here, and we are going to plug in our function, which was negative 0.1 x squared plus 600 x. Okay, now we're going to find the vertex and the axis of symmetry. We need to graph it first. If you hit graph, more than likely it does a terrible job of graphing. You can graph standard if you want to. Still does a terrible job of graphing. I'm going to go with zoom fit on this one, which is zoom 0, and it still just looks like a straight line. So sometimes you can hit whatever you want to on the zoom, and it just doesn't give you that great graph right off. So after that zoom fit, I'm going to go zoom out, and I'm just going to hit zoom out several times until I get a full view of this graph. The main thing I want to see on the graph is the vertex, and the vertex is your maximum point right here. So now that I can see that, I'm going to go second calc, maximum, and it's going to ask me to go left bound. So that point right there is left bound. I'm going to go past the vertex there. It's going to be right bound. I'm going to guess what the max is. I'm going to say it's about right there. Hit enter, and it finds it for me. The maximum is at x equals 3,000 and y equals 900,000. So that is our vertex. Our axis of symmetry is simply our x. So our axis of symmetry here will be x equals 3,000. And essentially what the axis of symmetry does, so if I can't exactly graph the axis of symmetry like I wanted to, but if I were to draw a line directly cutting this graph in half, that will be the axis of symmetry. Remember, symmetry means you can cut it in half and fold it on itself. Okay. Now it does ask us to find some additional points. So to do that, I'm going to go second graph. And you can pick as many additional points as you want to off of this in both the positive and negative directions. No problem there. Now we also want to know, where the graph is increasing and where the graph is decreasing. Now we have already found, second calc. We've already found that maximum point, which is our vertex and our axis of symmetry. I'm going to find it again, just to give us a bearing, so to speak. Just to give us a bearing on about where we're going to start and stop here on the increasing and decreasing. So, also I'm glad I did it again, because during your estimation, sometimes it doesn't get it 100% correct. If you notice here, that second time I did it, it said it's 2,999.9999999 repeating. Anytime you see that, just round it up. Round it up to 3,000. That's exactly what it means to be. It's doing an estimation function to find it, so sometimes it doesn't hit the nail on the head perfectly, but, I mean, if you round this at any point or juncture, it's going to round it straight up to 3,000. Anyways, where is our function and our graph here increasing? Now, from negative infinity, which is over here somewhere, on up to this 3,000 point on our x, it is increasing. After it hits that 3,000 and passes it, it begins decreasing on down to negative infinity. Okay. Now, the way we need to do this is just in respect to our x. Okay. So from negative infinity on our x here, on up to 3,000, our graph is increasing. Then from 3,000 on up to infinity, our graph is decreasing. And that is exactly how we're going to write it in your lecture notes. So let's get back over there and get all this information that we just found written down. Alright, so we're right back here. Our vertex we found to be 3,000, 900,000. Our axis of symmetry was x equals 3,000. We found some points. I'm not going to write those down because we didn't pick any particular ones out, but I showed you how to find them with your second table function. We're good to go there. We could list whatever points they needed us to. But we do need to state where the function is increasing and decreasing. So for increasing, it was increasing from negative infinity to 3,000, and it was decreasing from 3,000 to infinity. And that's exactly how we would write that. Now let's look at example 2. Example 2 says, using data from 1900 and projected to 2020, percent of the U.S. population that was foreign-born can be modeled by the equation y equals 0.0027x squared minus 0.3692x plus 18.9149, where x is the number of years after 1900. During what year does the model indicate the percentage of foreign-born population was a minimum? So, it also wants to know for B what the minimum percent is. So the best way to do this, in my honest opinion, is to go to your TI calculator, type this in your Y1, find your minimum, because that is your vertex point, and it's also your minimum, and it's a pretty easy process to do on the calculator. So let's get right back over to the calculator and get that done. Alright, so we're over here at the calculator. I'm going to type it in, 0.0027x squared. Oh, x didn't show up right. Having some technical difficulties. So x squared minus 0.3692x plus 18.9149. Got that all typed in. I can graph it. Who knows how it's going to show up. It clearly didn't show up well here. I'm going to do zoom fit. See what it does. Oh, that's pretty nice. You can see your minimum point here on your parabola, which is exactly what we want to see. Now we're going to go second calc. We're going to find that minimum point. Okay, so we're going to go left bound to the minimum point. We're going to go right bound to the minimum point. And then we're going to guess what the minimum point is. I'm going to say it's somewhere around in here. Hit enter. And it finds the minimum for you. The minimum is x equals 68.37 and y equals 6.29. Okay, so let's take that information, go back to our lecture notes, and see exactly what our answer is going to be here. Alrighty, so we found our x to be 68.37. We found our y here to be 6.29 at our minimum point. But it says, during what year does the model indicate the percent of foreign-born population was a minimum? Okay, so the x associated with it is our year, because x is the number of years after 1900. So if I was going to write it as an actual year, it would be 1968.37. Typically, they want you to round it to the nearest year, so we're going to say 1968. Be careful, though, because sometimes they ask you to round up. So if it asks you to round up, you would round up to 1969. Okay, so y isn't even a part of the answer. Our answer here, we're going to say, is 1968. Now, it does ask what the minimum percent is, and that is where your y comes in. So your minimum percent here is 6.29%. That is your y value. And we have answered question number 2. Question number 3 says, a ball is thrown upward at 64 feet per second from the top of an 80-foot high building. The equation below represents the ball's path. Okay, so we have s of t equals negative 16 t squared plus 64t plus 80. We want to find the t coordinate and the s coordinate of the vertex of the graph of the quadratic function. We want to graph the model, and we want to explain the meaning of the coordinates of the vertex for this model. The best way to do this, go ahead and go over to the TI calculator and find the maximum of this point. We know it's going to be a maximum because our a here, this negative 16, is negative, and that means it's a maximum. So let's go on over to the TI calculator, put this in, and find the vertex of this graph. Alright class, I'm over here at the calculator. I've already typed the function in. Take a second, type it in if you'd like to do and follow along with me. The function is negative 16x squared plus 64x plus 80. Now if we hit the graph button, there's no telling if it's going to show up. Doesn't look like it does. I'm going to go zoom fit and see what it finds for me. So zoom fit, making my graph look something like this. I can see that I have a maximum here, and I can find it. That's all I really care about. So if I go second calc max, I can go left bound here, right bound here, and I can go and guess where that maximum's at. It tells me the max is at 2, y equals 144. So x is 2, y is 144. Now, just for sake of this, I want to get a little bit better view of it so we can explain exactly and see exactly what's going on here. Okay, so I'm going to change my window a bit, knowing that the x was 2 at the maximum. So I'm going to change the x min to 0. I'm going to change the x max, let's say to like 16. And then at the maximum for the y was like 144. So y minimum, I'm going to let it be 0. And then y max, I'm going to let it be about 150. And let's see if we can graph it now and see what it looks like. Alright, that's a little bit better of a view for us. So what happens is this person is standing on the top of this building. They throw the ball up, it peaks right here, and obviously after that it falls to the ground. Okay, so its maximum point that it reaches, and we can calculate the max again if you'd like, it will wind up being the same thing. But the maximum point that it reaches, got to scroll left bound over it, might take me a second. But the maximum point that it reaches is the maximum height of the ball once it's thrown. So, like I said, x equals 2 and y equals 144. Now that 144 is that max height. That x equals 2 is your time. Because remember, x, we're letting it represent t, which is your time here. So at time 2 seconds, you reach your maximum height of 144. Now let's go back to the lecture note and put all that information down. So back here, t coordinate and s coordinate. T coordinate was 2, the s coordinate was 144. We already graphed the model. And we've kind of explained what the coordinates for the vertex in this model mean. So at time 2 seconds, the ball was at its maximum height of 144 feet. Pretty simple. Now something that we have to discuss now is the vertex form of a quadratic function. Now the vertex form of a quadratic function looks like y equals a times x minus h all squared plus k. The vertex of a parabola that's in that form is your h and your k. So your h and your k. The key thing to know here is you have to have a negative out in front of that h. If there's a positive out in front of that h, that means that your h is actually going to wind up being a negative number here. So keep that in mind. So we're given this example here, example 4. It says y equals x minus 2 squared plus 3. We want to find the vertex. Well, following the vertex form of a quadratic function, our vertex should be hk. Our h here is 2. That's a positive 2 because that negative is supposed to be there according to the form. And 3. Easy enough. Now a few points that we need to just kind of go over and make sure we have concreted down is that the parabola opens upward if a is greater than 0, and in that case the vertex is a minimum. If the parabola opens downward because a is less than 0, the vertex is a maximum. The axis of symmetry of the parabola has the equation x equals h, just your h value here, which is your x value of your vertex. And The a is the same thing as the leading coefficient in y equals a x squared plus bx plus c. So the larger the value of the absolute value of a, the narrower the parabola will be. Okay, so what we have here is two examples. So what I'm going to do now is I'm going to go over to the calculator for y1 and y2. I'm going to plot both examples and let you see them and let you see the difference in those two examples and how one of them, because the a is bigger in this y1, is narrower than the second one, the y2. Okay, so let's go over there and have a look at that. Alright, so I already have the two equations typed in. They're basically the same except the a out front. One of them's a 2, one of them's a 1. Okay, that one's kind of an imaginary one sitting there. Okay, so if I graph it, I'm just going to go, let's try Zoom Standard, see how well Zoom Standard does. Zoom Standard does a decent job. Now the first one we graphed with the 2 out front, notice how it's narrower here than the one with the 1, which is represented by the red curve here. So the bigger the a, the narrower the graph gets here. Good visual for you. Alright, so we're on to the next page of examples. Example 5 says the cost for producing X champion golf hats is given by the function c of x equals 0.2 times x minus 40 squared plus $200. We want to find the vertex of this function. The vertex is just hk. Pretty simple here, just 40 comma 200. We have the vertex of this function. It asks if the vertex is a maximum or a minimum. Judging by our a out front, our a is positive. Therefore, our vertex here is a minimum. Okay, got that checked off the list. We're good to go. Part C says describe what happens to the function between x equals 0 and the x coordinate of the vertex. What does this mean in the context of the application? Now, from x equals 0 to x equals the x coordinate of the vertex, which in this case would be 40. So from x equals 0 to x equals 40. Now, 0 is on the left-hand side of 40. 40 is a minimum. That means from 0 to 40, we have to be decreasing. And once we get to 40, we will start increasing. So there must be a decrease between x equals 0 and x equals 40. So what happens to the function? It decreases. So it decreases. And what does this mean in the context of the application? It means the more hats produced, the cheaper it is to produce them. Up until we produce over 40 hats. Essentially, our cost of production goes down from 0 to 40 hats. But after 40 hats, it starts rising again, guys. And you can graph this on your TI calculator and look at it, double check me, whatever you want to do. But after we reach those 40 hats, the cost of production actually starts to increase a little bit. And it kind of makes sense if you think about it. If you've ever ordered anything in bulk, usually up until a certain point for bulk, you start to get a discount. If you only buy one hat might be $15, $20. But if you buy 30 hats, they might cut you a deal and let every hat be, say, $8. But if you start getting an order for 4,000 hats, it might cost them a whole lot more to produce those 4,000 hats, because now, if they're only used to producing 40 hats, they might have to hire additional people, buy extra product in order to make those hats. Could get complicated here. Could get very complicated very quick, but in a good way. Alright, example 6. If the points in the table lie on a parabola. Write the equation whose graph is the parabola. Okay, let's look at these points. We've got negative 1, 13, 0, 2, or 0, negative 2, excuse me, 1, negative 7, and 2, negative 2. If we're kind of thinking about this, all right, I'm going to do a very rough sketch of this graph. At x equals negative 1, we're somewhere, our y is up here to 13. Okay, so points like right there. At 0, we're at negative 2, which we'll say is right here. So we've got a point here. At 1, we're at negative 7. We'll say that's a point right here. And at 2, we are back at negative 2. So if I notice something, I know it's a parabola. Looks like our vertex here is this point right here, 1, negative 7. And I did a terrible job of circling it. So, let me think about the vertex form of my parabola. That's y equals a times x minus h squared plus k. Okay, so if I know that that's my vertex, I can plug that point in. My x point is 1, so I get x minus 1 squared. And my k point here is negative 7, so minus 7. Now all I really have to solve for here is the a. In order to solve for that a, I need to choose a point other than the vertex. I'm going to choose 0, negative 2. Why? Because, well, if x is 0 here, it might make it kind of nice. That x is going to cancel out pretty quick. So let's try that one. Negative 2 for my y. A times 0 minus 1 squared minus 7. So 0 minus 1 is negative 1. Negative 1 squared is positive 1. That leaves me with an a there, minus 7. And a negative 2 here. I can add 7 to both sides. Okay. 2 plus, or negative 2 plus 7 is 5. So my a here is simply 5. So y equals 5 times x minus 1 squared minus 7. And now I have created the vertex form of this parabola. Now let's look at your last question here, number 7. It asks us to put y equals 2x squared minus 8x plus 5 into vertex form. Okay, let's work on this. Now, the a's stay the same. So our vertex form is y equals a times x minus h squared plus k. The a's stay the same, so I'm right here at y equals 2 times x minus h squared plus k. Now we typically just need to know the vertex. So if we remember our vertex form here, or our vertex, I'll scroll up so you can see it and circle it, because I guarantee you probably haven't done it on your lecture notes. You really need to. It's very important. So if we scroll up here, remember our vertex point here. Might even want to highlight it. Let's pull out the highlighter. I don't usually do that, but we can. That is very important. Negative b over 2a, f of negative b over 2a. So, if you hadn't yet, highlight that in your notes, because it's going to be important on this last question. Negative b over 2a. Okay, so our vertex here, negative b over 2a, comma, f of negative b over 2a. Okay, so what we're going to want to do is we're going to want to figure out what this point is. So negative 8 over 2 times 2. Okay, negative 8 is a positive 8. 2 times 2 is 4. 8 divided by 2, or 8 divided by 4 is 2. So we know that our h here is going to be a 2. Okay, easy enough there. Let's find what our k needs to be. So we're going to plug that 2 into our function. Easy enough, right? So y equals 2 times 2 squared minus 8 times 2 plus 5. Let's see, 2 squared is 4, times 2 is 8. 8 times 2 is 16, and we got that plus 5 here. Now 8 minus 16 is negative 8. Negative 8 plus 5 is negative 3. So my k now is just negative 3. So if I write my vertex form, it's going to be y equals 2 times x minus 2 squared minus 3. And we're done. And that completes chapter 3.1. So, go and attempt the Chapter 3.1 homework. If you have any troubles whatsoever, please reach out to me via email so I can help you with whatever you may be struggling with. Make use of your calculator, because a lot of your calculator functions will save you a lot of work in this. We could have actually found the vertex of this by just typing this in the calculator and finding the minimum point and let the calculator do the brunt of the work, but sometimes it's good for me to work it out by hand to show you it's easy to do by hand and to know multiple ways to do it. But try that 3.1 homework, get it completed, and then I will see you right back here for Chapter 3.2.